welcome to Real-Time Vehicle Tracking with Elixir and Phoenix, which was the title when I submitted the talk, but since then it's became Real-Time Vehicle Tracking with Elixir, Phoenix, and Nerves. So a little more buzzword compliant, I guess, and kind of goes with some of the theme of the conference so far. There's been so many great talks that mention and use Nerves. If you get a chance, watch them all. It's been awesome to see what people are doing. My name's James Smith. I'm a development manager at Gaslight in Cincinnati, Ohio, where I get to work with a great team of creative people. And we get to work on some really great projects and solve interesting problems every day, and I'm really grateful for having such a supportive team that lets me do what I do. And today I want to talk a little bit about a journey I had recently working on one of those interesting problems, where we added some real-time location tracking for an application for one of our clients. First, a little bit about my personal journey to Elixir. I've been working on Elixir, with Elixir for about 4 years now. I actually remember the exact date because there was a talk at the Cincinnati FP user group where Ryan Cromwell talked about Elixir, and functional programming was a little lost on me previously. I attended lots of our local user group, which is awesome. It was a lot on Clojure, and I didn't understand anything. I guess too many parentheses. I just wasn't ready. But then he presented on Elixir, and immediately all the things that had been leaking into my brain by osmosis suddenly started making a little sense. So I went out and bought the Prog book by Dave. This was Thanksgiving 2013. I spent most of Thanksgiving, to the chagrin of my family, reading through that, and I've been having such a great time since. We've been doing Elixir projects now at Gaslight for about 2 years. And as of today, about half of our projects are in Elixir. So, been having a great time. So, a little intro story. A client came to us with an idea. They had the idea that they wanted to build an app whose sole purpose was to stop bullying in schools, which was really cool. The idea was that they were going to deliver an application on the phones to students in high school that contained lifeline content, things like suicide prevention, anti-bullying content, things like that, which we were all about. The major problem they had was kids aren't just going to keep an app on their phone with that kind of information. It's going to get bumped for, whatever the kids are into these days. I wouldn't know. So the idea was that they were going to add some features to the application that would entice kids to keep this thing on their phones and get them to use it, and so that when they were in crises, they would have it on their phone, which was really cool. So they came up with an idea of making the application function as their student ID, which was a good idea, so that they would never lose their student ID because they're not going to lose their phone. The other idea was that they wanted to help kids get to school on time by not missing their bus. So they pitched to us, hey, wouldn't it be great if we could track the kids' school bus and show them where it was in real time? And I said, yeah, that's a really cool idea, and it sounds very, very scary and hard. So we encouraged them to focus on the core of their product, like we do a lot at Gaslight. And we went off and we developed some great Lifeline content stuff and some other functionality for them. But about 3 or 4 months later, real-time vehicle tracking came up again, and they said, hey, could you give it a shot? Like, let's prototype it out, see what it'll take. Around the same time, my coworker Tim was working on his artificial pancreas project How many people saw that talk? Yeah, that was really good. If you haven't seen that talk, go watch that talk. Tim is doing awesome stuff, and you should support him however you can. So around that time, he was working on that, and it really inspired me. And he came up with a saying as he was working on parsing some of the really difficult protocols that the pumps had. Elixir has made things that seemed impossible approachable. And so he finally convinced me I'd give it a shot, and we dove in and started exploring what it would take to add vehicle tracking to our client's application, which really looked like this. Reading lots and lots of manuals and documentation. See, our client had spent a lot of time in the time that we were working on other features. They had spent a lot of time going through and thinking about the logistics of bus tracking, and had already picked out an existing piece of hardware off the shelf, and said, "This is what you're going to have to integrate with." So that began the journey of what it was like for me to work with hardware, in particular hardware that I didn't create or control. And along the way, there was a few challenges, and hopefully what I'll be able to show by the end of this is what challenges we faced, and the fact that Elixir, Phoenix, and Nerves were all up for those challenges every single time. So the first challenge we ran into was the documentation for the hardware we were working with. It wasn't great. Most hardware documentation isn't, to be fair. But this was particularly bad, and it had some translation issues. Frankly, it kind of assumed you had a hardware background, which I did not. But on top of that, it was a pretty complex binary protocol. The hardware was designed for asset tracking of construction vehicles in China. And so it included a lot of features that we didn't need. And it was a very chatty protocol. When at the end of the day, really all I wanted was a latitude, a longitude, and a course, and some other things, which I didn't realize at the time. But Elixir came to the rescue with binary pattern matching. Binary pattern matching is great, and if you haven't done it, I hope you get a chance to, because it feels good to solve something that feels daunting with a simple language construct. Binary pattern matching helped us wrestle the complexity of the hardware protocol while letting us destructure the pieces that were relevant to us, and Erlang and Elixir's philosophy of let it crash meant that we could ignore messages we didn't care about and code for the happy path. And if we got something we didn't expect, which happened very often, we crashed, our updater service restarted, and everything went on about its way like we wanted to. The second challenge we had was dealing with the thundering herd of kittens. School buses. So the first school that they had picked out was one of the largest schools in Ohio. And they had around 500 or 600 school buses who were all going to be connecting to us through a GPRS network every 10, 15 seconds. So we were a little worried about that. But once again, the Erlang and Elixir ecosystem had a solution ready for us, and that was a library called Ranch. Ranch, if you haven't seen it, is an acceptor pool library. It's actually a dependency that Phoenix depends on, and it gives you an out-of-the-box connection pool that is ready to accept incoming requests. Kind of like load balancers for connections, or a pool of connections. Getting this set up was fairly easy. We just have a simple worker module that starts up a ranch listener, and we declare second parameter there, how many listeners we need. In this case, we started out with 1,000 because we knew we only had 600 or so buses, but we wanted to load test and just kind of see how that would go. And then the last thing that you pass is the module that is going to handle the connection once the connection's been accepted. And we ended up with something a lot like this, not quite the same, but where we have a gen server-like module that spawns a process and accepts an ACK request and then loops. And in that loop, we parse the payload and we update the location of our updater service, and we send back an OK message to the device and recurse, which was pretty cool. Wasn't too bad, and Elixir had a nice solution for us. So the third thing that we ran into was the logistics of dealing with school buses. So when we first started out, we wanted to get an idea of what the day in the life of a school bus employee was and what it was like to run a school bus garage. So we went to the school and met with Carolyn, who was the director of logistics at the school we were at, and we spent a full day with her, and it was really informative. Let me tell you, there are some interesting things that happen at school bus garages. It should really be a reality TV show, I think. Let's see, we had a school bus that had to be discontinued or decommissioned because a kid got very sick on it, and they could not clean it enough. We had a parent who wasn't there to pick up the kid at the house, and then they relayed back and called them. The parent was there, but it took them 25, 30 minutes to come out and pick the kid up. We had a bus breakdown. We had bus drivers who were accused of speeding, and they were not. Just a lot of things in the day-to-day. And it turns out that buses and hardware breaks down just like software does and can be brittle. So one of the things we realized early on is that we were going to have to associate devices to a bus, but that was going to have to be a very loose and often changing association. So that meant that we needed to be able to dynamically commission devices and assign them to vehicles, but be able to swap them really at the drop of a hat. So that meant our location and updater processes were going to have to be supervised in a dynamic way, which meant we needed to implement dynamic supervision. Jose talked a little bit about this morning, and I'm really looking forward to the new dynamic supervision. But the way that you do that right now is with a strategy called simple one-for-one. And so the way that works is you tell your application how to register a unique process using the registry module is what we ended up doing, and giving it the name of the registry. And then the next thing is you set up your supervisor to use the simple one-for-one. And you need to provide it a way of naming the process. In our case, we're doing it by the IMEI, which is the unique identifier of the GPRS hardware. And then that way we can look it up in the registry and stop the process or start it as we need to. This is pretty cool, but it's hard to set up, as Jose mentioned earlier today. So I'm looking forward to a simpler way of doing that. Then we encountered a fourth situation. So we got supervision up and running. We had an updater service. We were finally parsing our binary protocol. and things were good. We got to an exciting point. We had a dot on a map, which doesn't seem like much, but to a programmer, is super cool. Anytime you can do something with physical hardware, write code, and then see something move or blink, I get personally really excited, which was great. But we had a problem. We had this happen. The bus would move forward, and then suddenly it would go back about halfway, and then it would go forward again. And this actually took us a really long time to figure out what was going on, probably too long to figure out what was going on. But here's what we finally figured out. So we had a situation where we have a bus and a cell phone tower talking, and the bus is talking to the cell phone tower over GPRS connection. So the hardware sends a location update to Tower A, but Tower A is a little busy. There are a lot of people on Facebook that day, and it has a lot of connections. So Tower A is a little slow. Then time goes on. The bus moves down the street, sends another location update. This tower, not so busy. It's out in the middle of nowhere or something. It's very fast. So Tower 2 sends its message. Tower 1 is still lagging. You get order out messages of. So the nature of GPRS networks meant that we could not rely on the order the messages were going to come in and be received. And this is the case a lot of times in a lot of different domains, but this one seemed, for whatever reason, seemed to happen a lot. And it was a big problem. So I talked earlier about, I thought we needed a lat, a lawn. That was pretty much it, right? And a course maybe. It turns out we needed something else. We needed a timestamp. That is something that the hardware didn't have at the time. So we had ordered this off-the-shelf hardware from China, and for whatever reason, it didn't have a timestamp on messages, which was a problem. So our client got on the phone with the manufacturer in China, which was easy, let me tell you. And they sent us a file like a week later with something to flash the hardware. And so that was good. Now we had a timestamp. And so we were able to basically use our Gen server to sit in between our messages and then basically compare our timestamps, that's probably not the best way to do that, by the way. You run into things like time zones. But really, at the end of the day, if we got a message that was from the past, we just dropped it. Because really, all we care about showing is the bus moving forward. So we were able to solve that problem. It took a little bit to get there, but it happened. But that kind of highlighted an issue for me. So the hardware we were working with was designed for another purpose. Its whole purpose was tracking physical assets, and it was kind of like a load jack kind of situation. It had a lot of commands that frankly scared me. One of those commands, for instance, was oil pressure. The other one was remotely stop the engine. So these were going to be on school buses. And I wasn't comfortable with that. And the way that the write commands of the device worked was by connecting it up to the CAN bus on the vehicle. I don't know how many people have heard about the CAN bus or know what that is, but it is basically the bus on almost all vehicles today that hardware and different parts of the vehicle talk to. And it has been demonstrated several times as being very insecure. There's no encryption. and there has been demonstrated attacks and remote vulnerabilities. The famous one was a Engadget article, I believe, where they stopped a Jeep on the on the highway remotely. So this is the second time I had worked with hardware, and I had to come to the decision that I couldn't work with hardware that could affect a human in a harmful way. And so I had a conversation with our client, and they decided, okay, we're not going to hook it up to the CAN bus. We're going to go power only. And we were able to get around that issue, which I was really thankful about. But it was something to be aware of when you're working with hardware. You need to think about what the implications of the code you write could be. So the project went on. It was fairly successful, but it left me thinking that I wanted more control. I wanted to be able to ensure I, one, had only the things I needed, and also be able to know what my device was doing and how it was connected. So I talked to Tim again, and he encouraged me, hey, there's some hardware out there that you should look at, and I think Nerves would be a good fit for this. So we looked at it, and turned out there was a really cool piece of hardware by Adafruit called the FONA. The FONA 808 is a GPS shield by Adafruit Industries that is essentially a shield with a cell phone chip, SIM chip on it, that you're able to connect to and talk to over UART. The specs on that, it's got a lot of really cool features. It has SMS, connects to the GPRS network, 2G network. It has TCP/IP capabilities, HTTP, UDP. It has a buzzer so that you know when you receive a message. Has 22 different tracking locations, 66 acquisition channels, and is fairly accurate, up to 2.5 meters. Supports a speaker, microphone, and it has level shifting circuitry, which meant I didn't really have to worry about whether I was using 3 volt or 5 volt, which for me was good because I don't really know what I'm doing, and I don't want to release the blue smoke because hardware still scares me a bit. But what it really meant was it was time to read lots of manuals again. So I will say this, the Adafruit hardware is very well documented, as is most of Adafruit's products. I highly encourage you to check it out. The documentation is really good, but there's a lot of it. But really what it meant was I needed to learn a lot more about hardware. I didn't go to college for computer science, and I'm not an EE. And I had never really soldered before, except for with my dad like standing over my shoulder and yelling at me. But so I had to learn to solder and prototype hardware, and that was a really fun experience. But I learned a lot of things. Some of those safety tips. For instance, if you have a very long beard, do not let your beard get in the way of the iron. Do not touch the iron to your beard. It is a bad time. It smells very bad. So I soldered up the FONA and hooked it up to a Raspberry Pi Zero. Got the header pins on there and started to write some Elixir code. And what I discovered was writing code and then burning a firmware to the Raspberry Pi, and then discovering I have a bug, and then troubleshooting that code and doing this repeatedly wasn't a great workflow. So Tim, once again, came to my rescue and recommended a better workflow. This is the CP2104 Friend, also by Adafruit, and it is a USB to serial chip that allows me to do what it allowed me to do was rapidly prototype by connecting the phono directly to my laptop over USB, and then connecting to it from an Elixir REPL. So altogether, it looks something like this. Once again, blinky lights are exciting. So, but that was awesome. I was off to the races, and I was writing code. So I started to try to see what it would look like to write a GPS tracker in Elixir. So I wrote a small little wrap on the phono and wrote a simple location reporter. I know this is a lot of code, but really it's not much. All we do is on a NIT, connect to the serial device using Nerves UART, and then we make sure our GPS is on, and then send ourselves a message that says, hey, 10 seconds from now, I want you to report your location. Then we make sure the GPS is on again. We connect to the network, make sure the GPS is on again, and then we parse the GPS response. Now we have some control. We can only have what we need: latitude, longitude, course, a date time, and this fix mode means we have a fix or not. Then we open up a TCP connection and send a message out to our server, and then say, hey, send yourself a message again to report your location. We have a little bit of error handling. So not too terribly complex, but at the end of the day, we ended up with something like this, which my container packing skills is not the greatest, as you can tell, but we have a Raspberry Pi hooked up to the phono and a battery hooked to an antenna, and we were able to track locations, which I'd like to demo. So right now, my wife has that hardware in her car, and she is hopefully driving, and I'm going to call her up, and hopefully we'll be able to see that in real time. She loves this idea, by the way.
Hello?
Hey, love, how you doing?
Hey, James. All right, how's it going?
All right, you're on speakerphone. There's a lot of people here. Do you want to say hi?
Hi.
So are you going down the road?
Yep. Oh, I'm at a stoplight.
Oh, you're at a stoplight. Ooh. Okay. Drama. All right. So we're going to hang on the phone here a little bit and see if you move on the map on the screen here. Are the kids with you?
Yeah.
Hey, boys. How you doing? Good.
You put you on speaker.
You want to say hi?
Hi.
That's awesome. All right. So hopefully here we'll see the dot on the map move. That's the idea. Yeah, yeah. This, I thought this couldn't possibly fail. So, still at the red light?
No, we moved. Wonderful.
Awesome. Hey, all right. Thanks, love. I'll see you next week.
All right.
Have a good night. Bye, boys. Love you.
Bye.
Hand for my wife, everybody. So that was pretty cool. I can't believe it worked. So I have prototyped this out, and hopefully we'll be doing some more with it. But the next thing I would really like to do is work on a Hex package for the Phono, which I will hopefully be hacking on this week if anybody wants to pair up. The next thing I'd like to do right now, I'll show a little bit of it, but right now it really is a string of AT commands that I issue to do what I need to do. What I'd like to do is build a custom build route and get the PPP daemon running and be able to provide a internet connection to a nerves image using the system registry to let it know whether we have a GPS fix and whether it has a network connection, and using nerves networking. And I think it has a lot of really cool possibilities, and I want to see what people do with it. Tim mentioned the idea of, for his type 1 diabetes project, if someone's blood sugar goes low and they're out on a hike, being able to have an emergency contact where it would send out a message letting people know, hey, this person went low and this is their location. I think that's really, really cool. So I don't know how many minutes we have, if we have time to go through a little bit of the code. But yeah, let's look at some of it. I'm going to try to mirror my displays here, otherwise I'm not going to be able to see what I'm doing. Seven minutes, okay, cool. All right. So this, you're not going to be able to see that. This is really the state of the code right now. Can everybody, is that big enough, or do I need to? Okay. All right, so right now we're kind of just sending down. There's a really good documentation on the AT commands, but we're sending AT commands to the Phono and getting a GPRS connection and managing the state of that. We can power cycle the GPS and, that part, I'm sorry. The other thing is there's some basic handling for TCP. So I can show a quick demo of some of that, hopefully. So I have another Phono here hooked to the, oh, that was not the right thing. And I did it again. Typing is really easy with lots of people watching you, let me tell you. I have the Phono hooked up to my friend and plugged into my laptop. And now let's see if we can connect to it. So we've connected to the Phono. We asked if the GPS has power. The one there means that we do. And it's connected and ready to receive some commands. And let's see. Oh, that is not the right thing. So let's connect to the network. And hey, wow, we did. It worked. So we got this message back that says we're connected, and it's ready to receive commands. And so if we wanted to, we could send TCP messages up. I'm not going to try that because the connection's probably not going to be good. But this is pretty cool. We can have our tiny little Raspberry Pi running Elixir, talking over cell phone network, to another Elixir Phoenix server, and relay information that we're getting back from satellites in space. That's pretty cool. So that is all I have. If people have questions. I'd love to answer them.
Crazy cool stuff. We have 4 minutes for questions. Let's see some hands.
It seems like the most intimidating part for a lot of this stuff coming from software is the hardware, like you were saying, and kind of dealing with all these AT codes and stuff like that. How did you dive in and reverse engineer? Or was it just, you mentioned the documentation was pretty good, but.
Yeah, the Adafruit documentation was very good. The other hardware was definitely plugging in, reverse engineering, and I didn't have the great setup I had with the friend when I was working with it. So it was really just receiving commands, trying to parse things correctly, and following the manuals. But once I got the USB connected, it was the documentation for the SimCom 800 is pretty good, and Adafruit has all of the docs for the AT commands, TCP, all linked up there. The EagleCAD files, like, it's all open hardware, so it's pretty cool. But yeah, it was a lot of reading, to be honest, and talking to Tim and hanging out in the Nerves channel, which I highly recommend. The Nerves channel on Slack, Elixir Lang Slack, is awesome. They're friendly people and approachable. Please join and ask lots of questions.
I second that.
On the hardware side, I'm curious if you had any challenges or have any thoughts on how you're going to manage powering the thing in the buses, and what happens if power is irregular or goes out, or et cetera.
Yeah, so the Fona has a LiPo battery connected to it in case the power does go out. It's pretty good with power consumption, but the GPS does eat more power than the cell phone. Mostly the plan is to have a fairly large battery. With the 5,000 or so mAh, I can get about 2 days with the Raspberry Pi Zero and the Fona. So it's pretty good. And that's like 8 hours a day or so.
I actually had a question. So the SIM card chip uses T-Mobile?
Yes.
How much is that, honestly? I'm
Oh, yeah.
curious about the cost.
I should have said that. So I'm using Ting, which is the reseller, T-Mobile reseller. They have a pretty good data plan. All of these data plans are a little expensive, but not too bad. I get 1 meg for free and 100 megs for around $6 with a $6 activation, so it's about $13 a month.
Not bad at all.
Yeah, it's pretty good. Right now I have 2 devices, and I'm only using about 2 or 3 megs a month. So.
All right. Well, one more big round of applause, please.